Welcome everyone to our webinar today on warehouse automation and volatile demand. Today we want to shed light on the question whether automation can be a strategy to cope with volatile demand these days. To be more precise, we do not only want to answer the question whether, but also how and with which kind of process to approach this question. I have a couple of technical remarks, just four. As you noticed, the webinar is going to be in English to allow everyone to listen to it from all around the world. Second, we will record it, will be available on demand. We will send the slides to you after the webinar. And last but not least, very important, if you have any questions during the webinar, please feel free at any time to use the functionality of the GoToWebinar to ask the questions. At the end of the webinar, we want to answer the questions. We want to go into a discussion. Today, you will see 4 speakers from Foreflow. My name is Wendelin Groß. I'm the head of Foreflow Research. And with me, there's Alexander, researcher focusing on the supply chain modeling. We have Jan Niklas, our senior expert in intralogistics and production consulting, and Leonard, vice president Foreflow Consulting, and especially in the FCMG retail and medical tech business. A current challenge that we see in designing warehouse is to evaluate automation technologies under conditions of volatile demand, meaning how can we define which technology is the right one in case we have a lot of fluctuations of demands, we have a lot of peaks, and so on. To start with, what we must ensure in designing a warehouse at all time is efficiency. It's always a question how to make the best use of our warehouse resources in the daily operations. You see that on the right bottom corner of the triangle. On top of that, how can we deal with efficiency? First answer here often is automation. Automation has a potential to be highly efficient, to have highly efficient processes inside the warehouse. Nowadays, when we look at online demand rising, especially during pandemic phases, but as a general trend, also during warehouse design, we have to make sure that flexibility is given at all time. So this trade-off in the warehouse design is something that we find in our daily operations with our customers as very important. And therefore, our motivation was, let's have a deeper look into that. Let's try to model a warehouse situation in order to answer the question if and how volatility does impact automated warehouses, so to say. And that's what we've got for you today. On the agenda, after first a short introduction so that you know who we are, we will present our model and our results to you. And at the very end, we will come to a conclusion and discussion based on questions that you pose to us. In between, we will present as well the answers that you gave to us on the poll during the registration. And we also prepared a second poll so that we can even know more about who's in the audience. Let's get started. Please, Leonard, would you explain Foreflow to our audience?
My pleasure. Thank you, Wendelin. Okay, for everyone who doesn't know our organization yet, I've just brought a couple of slides just to provide you a good global overview of who we are. So essentially, we are a consultancy company who was founded in the year 2000. And as you can see on the right side, since then, we've had quite a significant growth. We are now over 650 team members globally with over 16 locations, being present in North America, South America, in China, and obviously also in Europe with the majority of our offices. We have over 300 global customers, and we do roughly per year over 200 projects across different industries and also across different supply chain areas that we would like to also introduce you today to. So if we go to the next slide, what do we do from a consulting perspective? So in general, we want to be the consultancy of trust to our customer when it comes to supply chain questions, be it inventory optimization, network and transport optimization, sales and operations planning, production planning, and very important as it is the topic of today, warehouse and production optimization on the shop floor. For that, we really have a specialized practice, which will be introduced in a second, just to provide you an overall overview of what our intralogistics and production portfolio looks like. We do a lot of projects in the area of efficiency improvements, so cost reductions and performance optimization, very classical, supporting our customers in increasing labor productivity, space productivity, and also the service level of warehouses. On top, we do material and information flow planning, which goes more in the direction of really greenfield planning for new distribution centers, greenfield planning for warehouses close to production, something which is not pure optimization, but really bottom-up planning. Another topic is the flow-based factory and warehouse design. I will explain that briefly. Essentially, classical lean concepts supporting our customers in coming from a more static flow inside of their operations to a really flow-based organization and flow-based design, which allows to reduce inventory, allows to increase efficiencies there as well. On this slide, we see at the bottom left the topic that we will talk about today as a majority, which is the warehouse automation and smart technologies, which over the last years has become one of the core elements that our customers are working with us together on, which is the question of which part of digitization, be it software applications, be it really technology hardware applications, what does make sense for our customers in their specific application case. And two additional topics is the tender implementation and ramp up support. So not everyone decides to really go for a make strategy, but we see for a lot of industries that the buy strategy, so really going with the 3PL is a little more common. So there we support on finding the right 3PL with the right warehouse setup and support also on the implementation. And last but not least, task force management. Everyone knows that in operations, if there is a new product launch or if there is a new warehouse that was set up or a new 3PL, we support on these day-to-day operations questions. If you need someone there on the shop floor who supports on fixing topics, that's what we do. This is really a really bottom-up shop floor support where our task force colleagues support on fixing issues short-term. To give a little bit more insights, as I mentioned, we do have a dedicated practice, which we would like to introduce. And for that, I will hand over to Jan-Niklas.
Perfect. Thank you, Lennart. Exactly. So we do have a dedicated practice around the topic of intralogistics and production at Foreflow Consulting. And what we're doing in this organization is we are gathering and collecting information out of the more than 200 projects that we are performing per year and having a huge database of interesting insights that we are able to also distribute into other projects for them to benefit from this information. But we're not just gathering information, we're also creating innovation. So our vision is autonomous logistics, autonomous intralogistics, and that's what we're striving towards on a global scale. We have experts all across the globe. So in all offices, you'll find at least one dedicated expert on intralogistics and production. And we, for example, were also significantly involved in this study that we're going to present today. The other unit at Foreflow who was also involved in this study is Foreflow Research. And for that, I'll hand over to Alex, who's going to introduce that unit.
Thank you, Niklas. Yes, I'll give you a short overview about Foreflow Research and what we do. At Foreflow Research, we work on a lot of different innovative topics within the area of supply chain management, and we mainly do this in 3 different ways. First, we work in research projects together with universities, with other companies, and we also publish our results, for example, in scientific journals, in specialized magazines, or as today's study, as a Foreflow study. In addition, we also develop innovative solutions directly with and for our customers, so our customers can benefit from customized innovations. And third, we also at Foreflow Research act as an internal service provider within Foreflow, and we provide the knowledge and that we gain and the methods that we develop to all business line at Foreflow, which are Foreflow Consulting, Foreflow Management, and Foreflow Software. An example for that could be providing market reports, market forecasts, or also develop specialized algorithms, for example. And on the right side of the slide, you see our main expertise. This lies from a methods perspective, mainly in the field of quantitative methods. And from a content perspective, we cover, for example, risk management and humanitarian logistics, supply chain sustainability, or also e-commerce. And today's study is another example for applying data-driven methods, for publishing our research results as a Foreflow study, and also as an internal service provider, we of course aim for our developed methods to finally reach our customers. And with that, over to you, Andy.
Thank you very much. Now, to close the loop that you have learned a lot about who's presenting, I want to share the information who's in the audience quickly. We asked that upon the registration towards the webinar, and seeing the different branches where the audience stems from. I'm very happy to see that we have participants all over the different areas of industry. So we see a lot of people coming from service providers, but as well manufacturing. We have retail, we have food logistics, we have consulting, such as we are, and we have automotive as well. And seeing that broad kind of interest group that our topic warehouse automation seems to attract, the second question we asked on the registration was very up to date or very from a current situation. If you faced a lot of challenge in your own operations caused by the COVID-19 pandemic, and not much of a surprise, 2/3 of the participants of the audience said yes, there were some challenges, while only 1/3 said it was normal. And nobody, again, not much of a surprise, seeing we want to talk about automation and volatile demands, said no challenges in the last, so to say, year. So I'm very happy that we have a broad audience here, that there's a lot of interest on that. And as already announced, I would like to invite you now to a little poll. We would like to be able to know about your current status in the process of planning a warehouse. So the question here is, from your perspective, in your personal situation, do you right now plan to design a warehouse? Are you currently in the process to do so? Is it something you plan quite short term ahead, let's say within this year? Or is it something more you are aware of, but you do not have it on the agenda right now? That would be for the next 2 years, maybe. And if none of that is true, then probably you would say, I did not plan anything about that. what I observe a lot when I talk to experts, to people out in the industry, is of course COVID-19, but as well increasing online sales. That is a trigger for some people or for some companies to to say, I have to do something about my warehouse. I have to make sure I can have all my assortment online that I want to, and to be able to fulfill any orders quickly. Thank you for the participation. One number I want to share as well. We have 27 attendees at the webinar. And again, if you have questions also later on in the more technical part, please feel free to share. Let's have a look at the result. Who is what did we have in the voting? So the biggest part of you, 43%, is more thinking ahead, saying you don't have that challenge right now, but you're interested in the topic. 29% say probably within the next 2 years, and each 14% is currently in the process or seeing how long such a process actually takes, about to initiate within this year. From my point, that's again very interesting, and I hope we can also integrate that in the further presenting of the findings of our study and our recommendations, how to actually go ahead when planning warehouse automation, warehouse projects. Thanks for the participation. I would like to go on now and step into the technical part, and Alex will tell us about the model and how to evaluate volatility and warehouse automation decisions.
Yes, thank you, Wenli. I will now guide you through the results of our Foreflow study about warehouse automation and volatile demand. And to start, we defined two main questions that we wanted to answer in our study, which is, firstly, if demand is volatile, when does an automated warehouse meet the required service level? And this is especially interesting because automated technologies can come with flexibility constraints. And the second question is, how can an automated warehouse be profitable? Or in other words, when do savings in process costs outweigh the high investment of automated technologies? And our goal was to answer these questions through a mathematical model that reflects warehouse. But soon we realized that there are many influence factors that finally determine if a warehouse is profitable and if the service level is met. And for that reason, our research design includes a case study technique. We developed a structured case study, which you can see in the middle of the slide, that covers 4 different steps. So in our case study, we start by defining the case study's requirements. We plan the required capacity for the company. We design 2 different layouts that we compare to each other. And for this layout, we also model the warehouse processes. And this case study then allows us an in-depth analysis of cost and performance, and to especially understand the interplay between different influence factors on warehouse automation under volatile demand. So I will now guide you through these different steps in our case study. First, our case company is from the food retail industry, and the handling units that we look at are pallets. And we start by defining the processes in scope, which is very important because we here need to clearly define the borders of the processes that we look at. Because this is then important to define the interfaces between processes and also to be very clear about the processes and their requirements, because this then directly impacts the choice of technology and the requirements for the technologies. So our case study, our case company here covers the transportation of pallets from the inbound area to the inventory area. Next, the storage and retrieval of pallets to the rack system. And then again, the transportation of pallets from the inventory area to the picking or the outbound area. And with these processes being defined, we continue by looking at the demand side of the requirements. And our case company forecasted an average daily throughput of 4,900 pallets. But it also expects a demand volatility of 17%, which means that the throughput deviates in average by 17% from the mean. And what this means, we can see here on the right, we see 3 demand scenarios that we simulated and all have the same expected volatility. And we see that the capacity requirements really differ a lot. So we can see the first peak here that exceeds 7,000 pallets a day, and we can see times of low demand that reach almost 3,000 pallets per day. And now the question, of course, is what's the right throughput capacity? Because the right throughput capacity should meet the target service level, which is 98.5% for our case company, but it should do so in the most economic way. So it needs to find the balance between idle capacity and warehouse utilization. And this challenge, as we can see, is more and more difficult if demand is volatile. So let's take a closer look at the capacity, at the throughput capacity plan. First, we defined 3 quite promising throughput scenarios, and those were 6,300 pallet movements per day, 6,600, and 6,800 pallet movements. And for these 3 scenarios, we then did an in-depth analysis of the service level, meaning that we simulated 1,000 demand scenarios, all having the same demand volatility and all covering the same total amount of pallets, of course. And for these 1,000 scenarios, we then did a service level analysis, and the result was that for 6,600 pallet movements, we can say that the targeted service level is met with a probability of about 99%. So we can conclude that 6,600 pallet movements is the throughput capacity that we go on with now. So with this throughput capacity being defined, we move on to the layout design stage. Now, for an automated and also for a manual solution, we choose the specific technologies and also their interfaces, and then are able to do a very detailed comparison of the manual and the automated warehouse designs. And we do that with the use of a 3D software, which was especially helpful to visualize our layout ideas, but also to discuss it with different stakeholders. And here we now see for the manual and for the automated solution and technologies that we focused on 2 cost-optimal layouts. On the left, we see that the manual solution works with 16 forklifts that do transport, storage, retrieval, and transport of pallets. And on the right, we see the layout for the automated solution that works with 5 stacker cranes and 10 automated guided vehicles. And as expected, we can see that the automated solution's design is more compact. So we see that the racks can be higher, and we see that less ground space is required. And for these 2 layout designs, we now move on and take a closer look at the warehouse activities. We now use methods time measurement to model the warehouse activities on a very detailed level to understand all the influence factors and time restrictions, for example. And after that, we use activity-based costing, which helps us to transfer different cost drivers like equipment, labor, or operational costs into the flow of one pallet that flows from transport to storage to retrieval and again to transport. And by doing that, we find that, as you can see on the right, the manual solution works. The manual solution, is mainly driven by labor cost, which is 70% of total manual process costs. And for the automated solution, we see that equipment is the main cost driver here. And even more interestingly, in the automated solution, our process costs are about half of the cost of the manual solution. It means that we confirm our expectations that process cost savings are possible with the automated solution here. So to sum up, we've designed two different warehouses, a manual and an automated one. And both of them can meet the required service level of our case company. And we know that the automated solution can provide savings in process costs. And the question now is, of course, when would the automated solution actually pay off? Meaning that when would the savings and process costs outweigh the high investment? And we wanted to address another question here for our cost and performance analysis, which is how robust are these layouts designed that we just showed? Meaning that if some of the influence factors develop different than expected, for example, changes in labor costs, equipment price might change, and of course, demand volatility might develop different than expected. What does this make with our warehouse designs? And would they still be profitable, or could they still meet the service levels if these factors change over time? And this question now Niklas is going to answer in the next section for you.
Perfect. Thank you very much, Alex, for this great introduction of our case study. Now it's a pleasure, or it's my honor, to tell you the findings and the results of our study. So before doing so, I would like to highlight once again what are actually influencing factors for the profitability of an automated intralogistics solution versus a manual intralogistics solution. And some of these factors we already had a look at before, but here we have 6 key factors that must be considered throughout the warehouse planning process. And I'll go through them one by one, and afterwards we'll have a look at the sensitivity between those factors. So first off, obviously, which is often missed in many projects, demand volatility needs to be considered. So how high is the coefficient of variation within our actual environment? This needs to be considered, and this is a major finding of our study, which we will see later. Stock out costs. So how much does it cost if our automation solution wasn't capable of getting out that specific pallet in time, according to the service level requirement? That is basically lost sales. And that's what we call stock out cost here in this case study. I think labor cost is pretty self-explanatory. Warehouse rent, so space cost, is going to be a factor that needs to be considered in order to evaluate profitability. The investment itself, so how expensive is the automation solution that I'm intending to invest in, and dual command. Well, dual command is maybe worth a couple of words. The dual command is a factor which give us the possibility to also evaluate the performance of the system, how efficient the automation system is working. Well, there is a difference between single commands and dual commands. For example, a single command is when the stacker crane of a high bay warehouse, automated high bay warehouse, is picking up a pallet at the retrieval point and taking it to the storage, putting it away, and going back to the retrieval point in order to get the next pallet. A dual command, in turn, would be if the stacker crane would pick up the pallet, bring it to the storage, and in the same process step, take another pallet from the storage and bring it back to the retrieval point. So having two pallets moved in one process. This is dual command, and the ratio of dual commands typically is a good indication on how efficient a warehouse is working. Now that we've clarified that these 6 key factors are important, we would like to give you an idea of how they interplay. And we did so by creating an interactive web application for you, which is accessible for free. We'll have a look at that right away, and I'll show you some examples on this web application. But beforehand, I would also like to point out that besides this interactive web application, which summarizes the results of our study, we also obviously created a very comprehensive PDF document for you, available for download on foreflow.com. All right, so I would say that we now jump into the actual application on the website. And therefore, I just need to quickly jump to my browser. And this is what you are going to see when you surf to this URL. As I said, this is available for free on our website. And first off, before looking at any interplays and interdependencies, we explain once again the framework that Alex explained a couple of minutes ago. So what are the baseline parameters, the 4,900 pallet movements per day on average? What is the labor cost factor, the baseline for that, the investment cost, the space cost, all that is transparent here. And then you can scroll through different influencing factors. And the first one of them is demand volatility, one of the 6 key factors which need to be considered. And in this diagram, you can see each blue dot represents one scenario that we calculated. And as you can see, the targeted service level of this case company is set at 98.5%. And now if we move this lever here, this toggle, you can see that the blue dot is moving in the diagram. And at the same time, the conclusion also changes. And what does this mean? Well, obviously, demand volatility has an impact on the service level that is achievable. Some automation, or the automation system that we modeled here, would not be able to achieve the targeted service level if the demand volatility would be too high, right? So we are below our targeted service level. This is important to know. An additional point is, what would be the impact if we look at stock out costs, so the cost of lost sales? And this is what we tried to model in this diagram here. As you can see, the setting that you chose in the first diagram is taken from above. And now we can see we have a baseline stock out cost setting. But if the stock out costs are increasing, meaning that if we don't get the pallet out, it is very expensive for us, you can see that the payback period of the automation system is increasing. So it will take longer to pay back the investment. And you can see that it's even further increasing when the demand volatility is even higher, right? So this is a good sensitivity analysis between stock out cost and demand volatility. Let's look at another couple of factors. We were talking about labor cost as well. How do they influence the profitability? That's what we see in this diagram here. So for example, if we look at a high space cost, a high labor cost country like Germany or Central Europe, we should do it like this and put the setting of the lever warehouse rent quite high, you can see that the impact on the actual payback period of the system is rather low. Whereas the impact of the labor cost is significantly higher if we have a low labor cost, right? So the lower labor cost, the longer it takes to pay back the investment of automation. I mean, it's quite common sense in the logistics world that this is like that, but here we have it simulated, and also we can see the interplay with demand volatility and stock out costs later on. In addition to that, we also looked at the investment cost, meaning what is the investment of the automation system, how is it impacting the payback period? You can see if I put the lever quite high, the payback period also increases, which makes sense. Let's assume we have a quite low budget system in place here, which has also quite low performance. As you remember, UL command represents the performance and efficiency of the system. And now, if we look at all those levers together in our configuration summary, you can see that the overall payback period of the system is very low at 1.5 years. So for most supply chain decision makers, that would mean, well, this is something we could invest in. However, what's important, due to the fact that we have a high demand volatility, the targeted service level cannot be fulfilled. So it's worth to not look purely at the payback period, but also at the service level parameters in order to take that into consideration. And now another interesting question would be, which levers are the most, have the most impact on the payback period? Obviously, you saw that in the diagrams before as well, labor cost has a significant impact. So if you put it to a very low level, the payback period of the system increases significantly. Let's assume we have a rather low labor cost setting. Space cost as well has quite a significant impact on the payback period. As you can see on the right-hand side, payback period is changing significantly. And well, the investment obviously also defines the payback period quite significantly. So if we increase the investment cost, the payback period will increase as well. But what I want to highlight here is that also demand volatility can impact your payback period. Let's see, now we have 6.1 years payback period in place. And if we are able to manage demand volatility better, maybe to a baseline level, we can reduce the payback period by almost more than 2 years. This is a very important learning out of the simulation, that demand volatility has a significant impact also on the payback period, not just the service level. Yeah, and this is also one of our major findings out of this study. Obviously, within the PDF document, you'll find more than enough details on how we calculated these interdependencies, the interplay between those factors. But this should be it for now. Please feel free to go surf on this website later on to try it yourself. Maybe try to model your personal warehouse environment and check whether or not there are some learnings you can take from there. And please feel free to ask any questions now in the question board. We'll be happy to answer them later on in the panel. And now I'll jump back to the presentation for Wendelin to conclude the results.
Thank you very much, and thanks everybody for listening. Now I would like to wrap briefly up what we found. Niklas already summarized some of it. I think from one perspective, we can see what does the model tell us. We have seen that quite in detail. On the other hand, I also want to include what do we know as experts, as people who've done a lot of projects in warehouse automation. And the lessons that we've learned is, let's start with the first one. Yes, yes, automation can, so to say, automation can fit with volatility. It might be, however, more tricky. That's what we've learned. In a very stable environment with very stable demands, automation is quite simple to evaluate. It's more tricky with volatility, but yes, automation still works. Second, very important lessons we learned from the volatility is we have to include it, let's say, correctly. We have to take it fully into account. We have to look at forecasting, at demand planning, so that this very important decisive factor, I would say, is part of our decision. And from my point, luckily, we have a lot of tools today. We have methods today. We have machine learning. We have artificial intelligence. So we are in a position to base our decisions quite well on data, on more data than maybe, let's say, a couple or 10 years ago. And last but not least, the third conclusion, the third lesson learned that I draw is we, of course, have to look specifically at the case. We have a lot of location-specific factors like labor costs, equipment, sometimes rent, which also can play a major role. So we cannot say one warehouse is perfect for any condition. We have to look deeper into that. And remains the question, yes, how? What shall we do? What can we do? And here we have to see the process. The truth lies in the process, how to get to our warehouse design. And there we propose a quite sophisticated three-step approach. What I already said in the lessons learned. First step, to look into the requirements, and clearly also here focusing the demand topic if we're in a volatile environment. To use modern tools to analyze what does the demand volatility, what role does it play? Once that data is set, then we can choose technologies that fit and define scenarios, maybe 3, maybe 2, maybe you need more, depending on other factors, and go into the modeling and derive a process cost model from the scenarios, because the layout, of course, strongly depends on the technology, and so do the process costs. Finally, in order to compare these scenarios, as we've seen in the model, we suggest to do sensitivity analysis and go into simulation to come up with a final decision. With this process, from our point, it's very well possible to use automation to ensure on our initial question, how can I be efficient, at the same time flexible, and make sure service level requirements are being met. I said already, please, if you have questions, ask them. You're still free to do so. I would like to start a discussion with all the speakers you've seen and answering on your questions. And also, I would ask, let's say, some of my questions. Let me have a look at the panel. And my first, let's start with a simple question, Leonard. I would like to ask to you that. We've seen now food retail as a case in what Alex and Niklas presented to us. Food retail has some specific requirements, and we've seen that in the audience. We also have people from automotive. We have people from machinery and so on. Therefore, my question is, do you think the results can be transferred to other industries? We have big warehouses for spare parts, for example. And do you think it's as well necessary to look into volatility in these cases?
Interesting question. So if I now look at my core industries, it's overall retail, FMCG, medical. I mean, these are in any case industries that are very, very heavily impacted by volatility, right? So for those industries, even if it's not food, it's a clear yes, right? There is, I think there is a lot of fear to implement automation because of not known demand growth or regional distribution patterns for the upcoming 2 to 3 years, right? But that's something that can be considered. I think the study very well shows that once you consider it from the beginning and do proper sensitivity, you will find a good solution. And if I now look at automotive, at the machinery space, what we've seen there in practical projects where we've done these business cases, it's the same thing. It might not be that the volatility is as drastic as in, let's say, as in the food industry, right? But you still need to consider it. Worst case, if you don't consider it, you have an automation warehouse which is too small within the next 1.5 years, and that's the worst thing that can happen.
Yeah, we definitely don't want that. Maybe a question towards data, also in the same direction. Now we've seen a lot 2020. We have seen a crazy year. And do you think it's a good year to start with as a basis for planning, designing warehouse, or what approach would you suggest? Seeing that maybe there's a mixture of data, or maybe there's some specialties in that year.
Yeah, good point. So usually we always take the last year and look at the volatilities over the last year to cover to cover seasonalities, to cover general demand growth, changes in B2B, B2C customer behavior, and so on. On the other hand, during COVID, we actually changed a little bit to looking more at the last 2 to 3 years, because there are some effects in 2020 data, right, that are not representative from our experience. So if the data is available, right, it always, from our perspective, if you go in the detailed planning like a warehouse, it makes sense to really do a proper volatility analysis over 24 months, I would say.
Mm-hmm. Yeah, so even more important these days to really have a close look into the data and not just take what's at hand to define the requirements on the warehouse.
Exactly. I think the year 2020 showed very well that not all volatility is driven by market demand, but there can be some volatility due to bottlenecks in your supply chain. There is volatility in demands because your company ran out of inventory, right? But the interpretation of the data is the core, right? It's really important to understand what's now market volatility, what's volatility that's caused by your suppliers, what's volatility that you caused yourself because you didn't have enough capacity inside of your network to manage the demand.
Wonderful. I have another question, which is more, maybe Niklas, you could say something. How did you investigate demand volatility in warehouse planning projects, and how do you incorporate its impact in the dimensioning of warehouse? So I understand it's focusing on actual projects, which you've done a lot of.
Yeah, sure. Happy to answer that question. I mean, Lennart already touched on that point, right? So especially in a project that we are performing right now, we're looking back into historic data a little further in order to get the COVID impact out of the analysis. However, what's also important is to not just look back, but also look ahead, right? It is crucial to also have strategic alignments on growth assumptions, be it by article group, be it by product cluster, be it by market. This is extremely important in order to be able to also look into the future in order to dimension the warehouse in the right way. And speaking about volatility, for this, we are obviously looking at the seasonality, and therefore we also are able to use very sophisticated algorithms in our research team, in our data science team, in order to be able to also cope with large data sets, which are apparent typically in retail, in the retail industry, but also FMCG, where large data sets need to be handled. And how do we incorporate volatility in the dimensioning. Maybe to make the last point, the results of this study actually are already incorporated in our warehouse dimensioning tools that we are applying on our project. So it was extremely valuable to have this study here also for our day-to-day work.
Very good, thank you. Maybe a question towards that on the timeline. What do you say, how long does it usually take in a project setting from the very first, let's say, requirement collection on a warehouse design until, let's say, not have it built, but until we can, say, come up with a suggestion on a warehouse design that then can go out in the market to collect offers and so on? Do you have experience there?
Yeah, absolutely. I mean, this depends obviously also on the scope of the project, right? Depends on whether or not I can apply a standard solution like an auto store or a small parts warehouse, or have a very specialized solution with also adjacent systems like conveyors, for example. This complexity is obviously also increasing planning time. But if you're asking me about a concrete value of time, I'd say we would need 1 to 2 weeks of data analysis, and then another 2 weeks in order to come up with first scenarios for warehouse solutions. So within a month or 6 weeks, we should be able to have first results. Yes.
Thanks. Certainly depends on the scope, on the size, and so on. But to get a first idea, Leonard, want to add something, or is that great? Yeah, then I have a question on Alex on the model. Can you also do the evaluation without a specific simulation model, or maybe I would say, how sophisticated do you think the simulation of demand has to be, and is it always necessary? What do you say?
That's of course a question that we ask ourselves too. Is it really necessary to simulate demand, or can we get to our solution in another way, in an easier way maybe? Because there are of course different ways, like following a rather qualitative approach maybe, or working on with mean demand, working on historical demand and trying to analyze these peaks, historical peaks, and based on that come to a good conclusion. What I would say, where the main benefit in demand simulation lies, is that it first helps you to get a deeper understanding about the underlying demand pattern and structure, and also the consequences of demand peaks. And in addition, with the simulation, you could of course get a closer look into what happens if demand peaks follow on consecutive days, for example. We have, for example, weeks with very high demand. And I think this is a real strength of demand simulation, that you can also work with the simulation and create demand scenarios that are maybe unlikely or that are new to your business, but it helps you to get a new to get better insights into that. And we of course found that the more volatile the demand is, the more benefits we see in demand simulation, because if it's more volatile, then we see some difficulties in working with mean demand, for example. So I think this is a very crucial thing here. And yeah, maybe another what I would like to add here from the practical side is that we developed standardized algorithms with the programming language R within the study, and we found that, yeah, as we mentioned before, these standardized algorithms also work in other settings, in other industries, in different time horizons, for example. And yeah, that's just what I would like to add from the practical side.
Okay, so I understand the modeling is quite an effort, but now the model is already there, so it's possible to adjust it to different scenarios, different industries, different questions even. Yeah, one more time. We answered all the questions so far. If you have any more questions, feel free to type it in. Otherwise, I hope you enjoyed our webinar. I'm very glad that yeah, everything seems clear. In case you have questions at any time, you're very welcome to contact us. As I said, we will send out the slides, and the video has been recorded, so you'll be able to go through it again. And finally, to close the webinar, again, I want to thank all the 3 speakers. Thanks for your time and for the insight. And hopefully we will see you again around in a webinar or in person once it's possible again. Thank you from my side. Have a nice evening and stay safe.
Thank you.
Thank you.
Have a nice evening.
Thank you very much. Bye.